purpose of this video will be to show you 3 examples from the textbook, problems 518, 521, and 522. All 3 utilize different forecasting techniques that we discussed previously, and we'll demonstrate these, and then we'll also demonstrate these same problems with the use of the software. Okay, so to begin with, 518 gives us a set of data and asks us to use exponential smoothing to develop a forecast for period 6. Okay, so the way we do that, it also specifies that we're going to use an alpha of 0.3, which provides little weight towards the more recent ones and a little bit more weight towards previous observations. If you recall, the exponential smoothing was we're trying to forecast the period in front of us, and we take the current period forecast, or the previous period forecast, and multiply times alpha times the actual minus the forecasted value. Okay, so we're going to plug those numbers in. The problem gave us a seed of 410. It said start out with a number of 410 for the first period forecast, because obviously we can't forecast the first period when we don't have data prior to that. So it said use that forecast to develop future period forecast. So what we're going to do now is we're going to take that forecasted value, f of t, 410, and we're trying to go for f of t plus 1, which would be 2. So we're going to use the data from f of t, which is 1, and we're going to take 410 plus 0.3 minus the actual, the 450, times the actual minus the estimated, and that turns out to be 422. Same thing in the next slot, but only now we move down a slot, we use the period forecast from the previous period. 422 plus 0.3, alpha stays the same throughout the entire problem, times the 495 minus the 422, and that comes up with to be 443.9. Do the same procedure all the way through until we come down to the period 6, which is what the forecast asked for. The problem asked for forecast. That's 521.8. So that's our first method that we've used to forecast period 6. Second method is in problem 521. It asks us to use a 3-year moving average. And what we do then is we're going to calculate using the previous period, the second previous period, and the third previous period to forecast the future one. We're going to divide that all by 3. We go back, and that's this formula right here, but we're using 3-period formula, so that's the one we'll use over here. So we can't do it for the first 2 periods because we don't have data prior to that. So we need 3 periods of data. So now to forecast for the 4th period of data, we're going to take the 518 plus the 495 plus the 450, sum those all up, divide them by 3, and we get 487.66. The second observation we could use is for period 5. We're going to take the 563 now, plus the 518, plus the 495, divide those by 3, come up with 525. The 6th period, we're going to take the 584, plus the 563, plus the 518, divide them by 3, and we get 555 for the period 6 forecast. Note that this forecast is different from the one that we obtained using the exponential smoothing, the 521 versus the 555. That's going to happen with the different procedures. We'll get different forecast methods. And then to determine which one is the best one is, if you recall from the previous video, we want to demonstrate or compare the different forecasting accuracy measures: MAD, mean absolute deviation, mean absolute percent error, or mean squared error. And note that this forecast error comes into play in all 3 of those. Okay, we just utilize it in a different fashion. So what we need to do is calculate a forecast error. And to do that, what we do is we look at remember the forecast error is the actual minus the forecast. So in this one here, we had 495, and we forecasted 422, so that math comes out to be 73. Same thing here, we're going to take the 518 minus the 443.9, so the actual minus the forecasted, we get 74.1, and so on and so forth, all the way down. We could do the same thing down here, but utilizing this different method, and we get a forecast error down here. What I'd like to do, though, is point out the differences. Note that each method is going to give us a different forecast error. So in the the case of the fifth and sixth observations here, we can see that 96.9 is different from the 75.34, and the 88 is different from the 58. So what we'll do is we then take these forecast errors, plug them back into those formulas over there, and then compare the MAD to this MAD, okay, the MAD obtained in the exponential smoothing and the MAD obtained in the 3-year moving average. Compare those two, and then the one with the lowest forecast error is the one that we would choose as being the best model. Okay. We could also compare the MAPE to the MAPE, but we don't want to compare a MAPE to a MAD or a MAD to a mean squared error or some other combination. It always sticks the same across the different forecasting methods. Okay. The software that we will utilize to calculate these exponential smoothing and the mean the moving averages provide these figures for us. It actually provides, it will provide each individual forecast error if you would like, or it will provide the MAD, the overall MAD, do all the calculations for you, the MAPE or the mean squared error. The final project that we'll look at, our problem, is 522, and that one is utilized, it asks us to use the same data and to calculate trend projections. Okay. So then what we do is we say that, okay, we're going to use a regression model or a trend analysis, and we're going to need to calculate B0 and B1, and then plug those into the equation. We wouldn't do this by hand, we'd use computer software. So I used Excel and generated this output, and then it said, what it suggested to me is that the intercept term is 421.2, slope term is 33.6. I plug in 6 because remember the data in this set was, the independent variable was 1, actually this would be the independent variable that we plug in, 1, 2, 3, 4, 5, and then this would be the dependent variable, and then the data for those two. And then what we do, or this would be, in that case over there, the data for f of t plus 1, and this would be the data for t. And then what we want to do is forecast this, so we plug in 6 to this equation over here, and that math gives us a 622.8. Again, compare that forecast to the other two, the 521 and the 555, and you can see that all three are different. So each forecasting method will provide a different output for you, or a different result for you. And then what you want to do is to determine which one, you would go back to the forecast error measures and choose the one with the lowest forecast error method. The computer software also generates several different alpha values if you wanted to plug that in to do some sensitivity analysis to see, okay, what happens if I change the alpha? It'll do a whole bunch of other things for you. And that's what we'll demonstrate in the videos or the clips that will be used to show you how to use the computer software. And we'll also show you how to do that in both Excel, especially we use POM for the exponential smoothing, moving averages, weighted moving averages, and then for the trend projections, I'll show you how to do it in both Excel and POM. And the reason being is that Excel provides statistical background or statistical analysis, t-test, f-test, and the POM provides, and Excel does not provide the forecast accuracy measures, but yet POM does provide those forecast accuracy measures. So then we would again compare those forecast accuracy measures and determine which method would be the best. Okay, so what we did here in this one is we showed you how to do 3 different problems: the exponential smoothing, trend projections, and moving averages. All are slight variations off of these other ones. The next video will show you how to do these problems in Excel or POM.